Alright, let's do some practice on a velocity versus time graph. Okay, first question, what is the velocity from 2 to 4 seconds? Okay, so here's 2 seconds, here's 4 seconds. Let's see here. That means we've got that and that. So they want to know the velocity from here to here. What do you think it is? Hopefully you did not say 0. Okay, remember, the slope of a line on a velocity versus time graph is acceleration. On a velocity versus time graph, you can just go ahead and read velocity right off of the y-axis. So it was 20 meters per second. Alright, next question. What is the acceleration from 2 to 4 seconds? Good. That one was 0. Remember, it's the change in velocity. Did the velocity change at all along that line? No, it was always 20. So that means the acceleration was 0. What's the change in displacement from 2 to 4 seconds? Remember, on a velocity versus time graph, the displacement can be obtained by looking at the area under the line. And that's supposed to be hitting the 2 there. Alright, so this area of the rectangle is going to be our change in displacement. So let's go ahead and write that down. That would be the base times the height. The base is going to be the 4 minus 2, so that's going to be 2, times the height. The height here is the velocity, alright, the change in velocity. So that's going to be 20 minus 0, so 20. Alright, so that gives us 40 meters. Alright, so that object traveled 40 meters from 2 to 4 seconds. Alright, what is the object doing from E to F? Alright, so here's E and here's F. What is the object doing? Okay, good. It is decelerating. Decelerating. Alright, that means that its velocity is changing in the negative direction. The object is slowing down faster and faster. Alright? Or has a faster rate of slowing down, if that makes any sense. So is it moving from E to F? Is the object moving? Yes. The object is still moving, it's just slowing down while it's moving. Alright, what's the object doing from B to C? What is the object doing there? Okay, it is moving at a constant 20 meters per second with a constant acceleration of 0. Okay, so the object is moving. Let's look at some of these other things. What's it doing from F to G? What's happening? What can you tell me about the acceleration there? Okay, good, the acceleration is 0. Again, we have a horizontal line. What's the velocity from F to G? Okay, what is the velocity from F to G? Okay, good. Hopefully you said it was that 20 meters per second again. And what's the object doing from G to H? Okay, good. It's speeding up. Alright. The acceleration is increasing. It's got a positive acceleration. The acceleration is constant because it's a straight line. The velocity is changing. The velocity is not constant. Alright? Notice that you have a velocity here and a velocity here and a range of them in between. We have a velocity of like what? 30 and this one's 20, so that's a 10 meter per second change in velocity from G to H. Okay? Alright, let's do a review of our position versus time graphs. Alright, if we have a downward slope or horizontal, or we could have positive slope on a position versus time graph, what can you tell me about the velocity and the acceleration? What can you tell me about the velocity and the acceleration of these lines? Remember, we're on a position versus time graph. Okay, since they are all straight lines, you should be able to tell me that the velocity is constant. And using our definition for acceleration, if the velocity is constant, meaning it's not changing, then the acceleration must be 0. Alright? Alright. What if on our position versus time graph we have some sort of an upward curve here? What can we say about the acceleration of the object in this graph? So we have here that the velocity, the slope of the parabola here, starts out with a negative velocity, as you can see with the line there. So remember, the velocity is the slope on a position versus time graph. So we start out with this negative slope, and then as we move around the graph, we get a velocity that is 0, and then it starts increasing as we get to the far side of the graph. Okay, so that shows us that the velocity got less and less negative, then it was 0, and then it got more and more positive. Alright, so less and less negative, 0, more and more positive. Okay, so the velocity was changing in a positive x direction, which means that the acceleration must be positive. It must also be changing in a positive direction if we have this upward slope. Alright, what if you had any part of a downward facing curve or parabola for your position versus time graph? Okay, what can we say about the acceleration of this graph? Alright, well, first let's talk about the velocity. Okay, remember again, the velocity is the slope on a position versus time graph, and the velocity on this graph starts out as positive, and then it begins to get less and less positive till it hits 0, and then it becomes more and more negative as we move along the graph. So the velocity is changing in a negative x direction, and since the acceleration is equal to the change in velocity over change in time, and the velocity is getting more and more negative, the acceleration must also be negative here. And that would be true. It doesn't have to be a whole parabola on this one either. Any portion of this graph would give the same results. The acceleration would be negative along any part of that graph. Alright, let's use these bottom graphs down here for some practice. I want to see what we can come up with for the velocity and acceleration of each one of these, if it's positive or negative. Alright, so what can we say about the velocity and the acceleration of this first graph? Is the velocity positive, negative, or 0? And is the acceleration positive, negative, or 0? Okay, well, on a position versus time graph, the velocity is the slope, and we have a downward slope. So the velocity here has to be negative. Alright, what can we say about the acceleration? Alright, the acceleration here is part of an upward facing curve. Alright, so that means that the acceleration here is positive. It's speeding up. Okay, what can we say about the sign of the velocity and the acceleration on this graph? Okay, the velocity must be positive because the slope is moving upward. The acceleration must be negative because it's part of a downward facing curve. The change in the velocity along this curve here is getting more and more negative. Alright, and what can we say about this graph over here? The velocity must be negative because it's part of a downward facing slope, and the acceleration must be negative as well because it's part of a downward curve. The velocity is continuing to get more and more negative as we go down. Alright, let's take a look at these bottom three graphs here again, and I'm just going to number these real quick. And let's see which graphs have where the object is speeding up and which graphs show the object slowing down. Let's see if you can figure that out. Pause the video if you need some time before I explain. Alright, so notice here in graph 1 that the sign of the velocity and the acceleration are opposite of each other. That means that the object is slowing down. The velocity is in the negative x direction. Okay, so it is heading down here towards the negative side. Remember, this is the positive x and this is the negative x. Alright, so the object is moving towards the negative x direction. So if you had a Cartesian coordinate system, the object would be moving in this direction towards the negative x-axis. Okay, so and the acceleration though is positive. Alright, so since those things are opposite to each other, the object is going to be slowing down. Alright, so looking over here, the object is moving in the positive x direction, so it's moving this way, but the acceleration is negative, so the object is again slowing down. And then finally, we have an object moving in the negative x direction, and the object has a negative acceleration, so it's speeding up. The signs are the same. So it's getting faster in this direction. Alright, we'll leave it there for today. Thank you for learning with me, and I will see you next time.